Hello, this is Dr. Liu. In this video, I will demonstrate how to do a problem with an inclined plane with friction or without friction. So this question is from University Physics, published by OpenStax, Chapter 8, question number 38. So a 100 kilogram man is skiing across level ground at a speed of 8.0 meters per second when he comes to a small slope 1.8 meters higher than the ground level. That means this way, up vertically. Although this skier seems like a giant, this 1.8 meters just barely up here is, I don't know, this is maybe knees. So the figure is not to scale. Alright, so we have two questions. A, if the skier coasts up the hill, what is his speed when he reaches the top plateau? Assume friction between the snow and skis is negligible, so no friction. And then what is his speed when he reaches the upper level if an 80 Newton frictional force acts on the skis? So let's start with the first one. What I have done in the past is just to number this as a 1. This is like a snapshot of the skier with his position, his height, his velocity, everything important to us is taken in that snapshot. And here is a snapshot 2. Same thing happens just at a later time, different time. And I like to write this out. Mechanical energy contains kinetic energy and potential energy, and kinetic energy is 1/2 mass velocity squared. Potential energy is just gravity, mgy. So now I'm reminded I need to set the origin for y. So why not just starting from the levels, this level ground? So we just point upward. So here's our y-axis. Here's a 0. Okay. So now I want to say that E1, that is the mechanical energy of the skier in this snapshot 1, it is equal to E2. That's mechanical energy of the skier, same skier, a later time in this snapshot of energy. So now I can write down what is E1. So E1 is going to be these two terms. So 1/2 m v1 squared plus mg y1, and realizing that my origin is at this height, this skier has 0 height, so it is just 1/2 mv1 squared plus mg times 0. So I'll just toss this term and I have 1/2 mv1 squared. Alright, so we know the mass. The mass of the person is 100 kilograms. We know the speed is 8, but I'm not really going to plug in the numbers just yet. So let me work on E2. So I'm working on E2. This is all pretty redundant, but I like to write it out so I can show anyone what I'm working on. This part is the formula, and then the rest is I'm plugging in values. So although you're not required to show this, doing it shows me that you know what this energy is about. They have these terms, and then you can specify the value, any known values in these terms. So now that he's up here, he has a different speed and a different height. Okay, we know that y2 is equal to 1.8. Okay, so equating the energy, we can say that this equals this whole thing. So 1/2 mv1 squared is equal to 1/2 mv2 squared plus mgy2. Okay, because I have m in all of the terms, what I'll do is multiply this whole equation by m, and I'll just multiply by 2m since there's some 1/2s I like to get rid of. Oh, sorry, not 2m's, 2 over m. 2 over m. Okay. So now I'll multiply by 2 over m. I will have v1 squared equals v2 squared plus 2g y2. Okay, so since the question is the speed v2, I can solve for v2. So let's start from here. v2 squared is equal to v1 squared minus 2g y2, 2g y2. So v2 is equal to the square root of v1 squared minus 2g y2. And now I think it's best time to plug in numbers because we can't really simplify this anymore. So 8 squared minus 2 times 9.8 times 1.8. Let's do a better 8. And we'll use Python to do this. So start parenthesis. So 8 squared 64 minus 2 times 9.8 times 1.8 and close parenthesis raised to the power of 1/2. So we have a speed of 5.36 meters per second. 5.36 meters per second. I like to keep 3 sig figs so I can get well within 5% of the expected value. Okay, so now we found out the speed and we're done with part A, and we need to move on to part B where there's a friction. So what's the difference between these two parts where there's friction? What does friction actually do to mechanical energy? I think we know that it takes away some mechanical energy. And the amount it takes away is the same as the work it does. Well, it's negative work, right? So the work it does to the skier's skis. So the skier just basically moves up 8 meters along this slope. So friction, if it's along the slope downward, will actually be doing work frictional force times the displacement. So that is how much mechanical energy will be lost instead of maintained, right? So let's say work done by friction. So work done by friction is frictional force times displacement times angle between the force and displacement. We know the force is 80 newtons and displacement along the inclined plane is 8. Is not 1.8 because friction points along the slope downward and the displacement along that is 8 meters. Okay, and there's a cosine of 180 degrees. Which gives you a -1. So minus 640 joules of energy is taken out by friction. So to make energy conservation again, we'll now need to include this, right? So E1, and you do some work. This is a negative quantity, right? Negative quantity. This is the same as subtracting this much energy from the original energy. Now we arrive at new energy, which is less, right? So this is a more generic version of energy conservation beyond mechanical energy conservation. So let's work out the numerical portion. We can't really do anything with symbolic after this point. So we have these numbers. These are the values already included. So we'll just pull them off the earlier steps. Minus 640 equals 1/2 m v2 squared plus mg y2. We can still proceed to do this times 2 divided by m. M is 100, so this is the same as divide by 50. So whichever term has the m is gone, and then multiply by 2. So we have v1 squared minus 640 times 2 divided by 100, so that's 1280 divided by 100. So 12.8, right? So then the next term is a v2 squared, and then the next term 2 over m, so 2gy without the m, 2 times 9.8 times the y is 1.8. So our v2 squared is equal to, the left side is this v1 squared is 64 minus 12.8, then also minus this whole thing, minus 2 times 9.8 times 1.8. Let's use our calculator. So 2 times 9.8 times 1.8. So 35.3. So this whole thing is 35.3. Let's call up the calculator again. So 64 minus 12.8 minus 35.3. So we have this much left, 15.9. And let's take a square root. 3.99. So 15.9 here. 15.9. And take the square root, 3.99 meters per second. And as compared to without friction, it is slower. That is what we expected. Thank you.